That if you just would have took a second and turned to the last page, it says converse is switch these two statements. So if I switch my hypothesis and conclusion, we're going to have if, and I'm going to shorten this, if it has 4 sides, then it's a rectangle. Once again, that's not proper English. We're just doing it for the sake of time. You switch your hypothesis and conclusion. That is your converse. Your inverse, you keep it in the same order, but what do I add to it? I keep it in the same order. I just add kind of one word to it. Not. I need to add not to it. So it should be the same exact order, but with not in front of it. So we keep the hypothesis in the same place. So that's if a figure is a rectangle. So this is going to be if not rectangle, then not 4 sides. That was the one that we had up here. So we look for not rectangle and not 4 sides. You would have picked B if you wanted it correct. B was correct. Now, a lot of us picked C. C was actually the contrapositive. The contrapositive is a fancy word, so you have a lot of stuff going on. The contrapositive is you flip it and you knot it. Contrapositive, fancy word, you have to flip it and knot it. So we need to flip that hypothesis and conclusion and add the word not to it. So that would be if not 4 sides, then not rectangle. Questions on it so far? All right, we do have a quiz. I think on Monday. I think we have a Monday quiz. You got to know this stuff. You got to know how to write these. I can't go home and study this for you. You have to know that a converse is when you flip it, an inverse is when you add knots to it, and a contrapositive is when you flip it and add knots to it. Okay, truth values. If a figure is a rectangle, then it has exactly 4 sides. Can you think of a rectangle that doesn't have 4 sides? No. So that would be a true statement. Now, it starts getting a little more confusing when we start flipping stuff. So if it has 4 sides, then it's a rectangle. Remember, this is read, yes, it is going to be false because it's read as if it has 4 sides, then it must be a rectangle. That's how if-then statements work. If you have 4 sides, does it have to be a rectangle? No. What would be a counterexample to that? A square. A square has 4 sides, but it's not a rectangle, so that would be false. Yes? That's fair enough, but it's a special type of rectangle. But we could pick ones like, we could say, we could draw something too. If I was on a test, I could just draw something like that. Nope, that's terrible. That's terrible. That wasn't straight lines. Let's use straight lines. More like a trapezoidy kind of shape. Probably a better example. So I do agree with that. Okay. Our next one says, if not a rectangle, then not 4 sides. So this is saying if it's not a rectangle, then it can't have 4 sides.
True. False.
If it's not a rectangle, then it cannot have 4 sides. Didn't we already say there's shapes that aren't rectangles that have 4 sides? Yeah. Yeah, that's what it's saying. So if it's not a rectangle, then it does not have 4 sides would be false, because there's shapes that aren't rectangles but also have 4 sides. Our last one says if not 4 sides, so if it doesn't have 4 sides, then it can't be a rectangle. True. If you remember from yesterday, I looked at your notes, this first one and last one are conditional and contrapositive are equivalent statements, and your converse and inverse are also equivalent statements. It's a nice little shortcut. So if I'm trying to relay what's true and false, if I figure out this one's false, I know the inverse is false. If I know the conditional is true, I know the contrapositive is true. It's a nice way to just double check to make sure you did it correctly. Griffin.
Will we ever get a conditional that isn't true?
Not for this stuff. Most likely. But you should just double check. If I make you have a truth table next to it, if I don't have anything truth to it, it must be true. Bless you. Okay, so you're going to know to check if I put truth next to it, or if I say state a counterexample if it's false. Then you know, okay, I'm going to start looking to see if it's false. If I have nothing by it, then you can just, oh, it must be true because we're doing stuff with it. Other questions on this? This will be on the quiz. You can picture it almost looking like this, where I give you a statement, and I ask you to do a converse, inverse, and contrapositive. I always remember contrapositive is a fancy word. That's where everything happens to it. All right, so one more time. You have your conditional, converse flip, inverse knots, contrapositive flip and knots. Kind of hard for my arm to do that, but it works. Okay, if there's no questions on the bell work, then what questions do we have on the homework? Yeah. Number 9. Number 9 says, so number 9, I actually put a star by it because we could actually look at it as being both true and no conclusion. As I wanted it written, I wanted it to be no conclusion, but I made a mistake. And let's point this out. So we're going to see if we can use syllogisms, if we can connect these two statements together. So remember, the syllogism says, if the conclusion of one statement matches the hypothesis of the next statement, you can link the first and last part like dominoes. So our job is to look at the hypothesis of the first statement, which is you will improve your score on a standardized test. And then we're supposed to look at the hypothesis of the next statement. Do those match? No. I wanted the answer to be no conclusion. I wanted it to be written as you have to read it in the order I gave it to you. However, a lot of you out there with emails I got realized that, well, if I take the conclusion of this statement, does that match up with the, I'm sorry, if you take the conclusion of our second statement, does that match the hypothesis of the first statement? Yes. It says the exact same thing. It says, you will improve your vocabulary, you will improve your vocabulary. So if you read it backwards, you can actually use the law of syllogism to say, if you read often, then you will improve your score on a standardized test. So if you can write it out of order, yeah, this is correct. This would be law of syllogism. If you have to read it in order, then it was a no conclusion statement. I'm most likely to put it in order, but if it's out of order, I might put in the directions, these may be out of order. Remember, like last night's homework, I told you the next section were out of order, you had to put them in order. So if it says something about you need to order them, I will make sure this doesn't happen on the test. I'll make sure this doesn't happen where there's only one clear answer. I think this is a good example. Everyone should have looked at this and paid attention with me because that's both answers. It was no conclusion one way, and it was you could have a conclusion the other direction. It really gets to the heart of how syllogisms must work. That has to be conclusion to hypothesis. The second statement, conclusion, match the first hypothesis. So you could do law of syllogism. Does that help answer that question? Cool. And Michael, did you have a question?
Yeah, I just want to know the thought process behind 15.
Sure. The thought process behind number 15, everyone should be turning to 15. Whether you have the homework done or not, you should be turning to 15 just to get some insight. So 15 says every high school student likes art. At this high school, they do. So every high school student likes art. So we have to write an if-then statement about that. So I have two things. I have to be a high school student, and I have to like art. So that's going to be where I divide my hypothesis and conclusion. That first you have to be a high school student, and then you have to like art. So breaking that up, I'm like, if you are, or you could have a name. We could put if Michael is a high school student. We just need some kind of English so it doesn't just say, if high school student, then like art. So I'm going to say something like, if you are a high school student, then you like art.
Wait, I put if you like high school, then you'll like art.
It doesn't say you have to like high school. It just says you have to be in high school because it says every high school student likes art. So you just have to be in high school and then like art. So first you have to be in high school, then you have to like art. That's why I have, if you're in high school, then you like art. Okay? Then it goes on to say Ling likes art. That matches the conclusion, not the hypothesis. It has to match the hypothesis. It would have to say Ling is in high school for you to be able to say they like art. So we can't make a conclusion. Because there's people that aren't in high school that like art, probably. I would assume there's like artists and stuff. They probably like art. So you got to be very careful about these, that they match the hypothesis so you can get a conclusion from them. They do get tricky like that, though.
And,
But, yeah.
On number 14,
Yeah.
put for the hypothesis, if the temperature is always above 32 Fahrenheit, then it's in Key West, Florida, but like,
Gotcha. So,
I don't know if that's...
okay, can we all look at number 14? 14 is probably, it's probably a difficult one because, remember, your statement has to be true to begin with. So if we put, if the temperature is always above 32 degrees, then you're in Key West. Are there other places where it's always above 32 degrees, pretty much? Yeah, so it's not a true statement. So what I did is I flipped it to make it a true statement that said, if you are in Key West, then the temp is always above 32 degrees. Would that be something you have to be able to show me on a test? Probably not. I'll probably pick something a little bit easier. But that one really gets to the heart of that first statement needs to be true. When you're giving it to me in more official capacity, you're not going to have to make, the statement will come true to begin with.
Okay.
Is that a little clear?
Yeah.
Okay. All right, other questions? Those are great questions. I'm glad we went over those. Yes. All right. Any other questions? Questions going once? Going twice? And we should preface that with most of the time, like some of those like really warm places around the maybe around the equator, they're almost always above. But it's hard to say always because you have that like one cold front that came through. Okay. All right, there's no questions for me. We are going to go on to starting out what? All right, before we begin, can I real quick, did everyone get one of those packets from me? You might want to keep those packets. You might want to keep those packets and you might want to start going through them. You can use those on the test. If you lose it, you have to either print it out by yourself or you can't use it on the test. So don't lose those. Just like your Plicker card, don't lose those. You can use those on the test and we'll print out more for the next unit. So keep track of where this sheet is. And maybe the first thing we'll talk about is the first side of the sheet. Let's not push through on the homework. Let's make sure we listen to homework questions and stuff. All right, so I'm looking at the first side of the sheet, and let's look at some important information on here. So let me just take a quick picture. I'm going to take one more over here. These are not all the properties you need for tonight's homework, but these are the majority of them that I'm going to go over right now. Now, we have some stuff that we need to know because we're prepping ourselves to having to write this stuff over and over and over. So if like Tito's not paying attention, he might miss out the fact that we can write these things a little bit shorter. Properties of equality. We've already done properties of equality. You just haven't put them as properties of equality. The first one is the addition property of equality. All the addition property of equality says you can add a number to both sides of an equation. So if I had something like x minus 2 equals 4, you add 2 to both sides, and you come up with x equals 6. That is our addition property of equality. Now, before we start talking about these, I'm going to shortcut this a little bit. A lot of times I'm going to call it just PO. Properties of equality, because we're going to have to write these a lot. I don't want to have to write properties of equality every single time. So POE works for properties of equality. So you hear me say like add PO sometimes. I mean addition property of equality. Like subtraction property of equality, I could call it subtract PO. So every one of these we can rewrite as just PO instead of properties of equality. Well, subtraction property of equality, you can subtract on both sides. Multiplication, you can multiply on both sides. For division property of equality, you can divide on both sides. Now, I'm going to quickly box all of these in, and you can box these in as well. Whatever I write on here, you can write on there. The only time I have to use properties of equality are for these four, and you have to. It is not correct if you just say addition. Addition is different than the addition property of equality. One says I can do it on both sides, one says I can add stuff. So if you are using one of these four, you have to write property of equality after. The rest we do not. The first one, reflexive property. You are equal to yourself. A is equal to A, 2 is equal to 2. The reflexive property can be used, not a ton. Basically just says you are yourself. Symmetric property is used a lot when we need to reorganize stuff. So it says A equals B, then B equals A. Let's say you have an equation that ends in 2 equals X. You know, most of the time we then write it as X equals 2 and box it in, because we don't usually put that out of order. That is actually using the symmetric property. The symmetric property allows you to flip stuff. Transitive and substitution properties. I'm going to put a star by these, and you can put a star by them as well. They're used a lot, and a lot of times they can be used almost interchangeably, but they're slightly different. Let's talk about these two. So the first one is transitive property. I like to call transitive property the transitive property because it chains a whole bunch of things together. It is a syllogism. This is if A equals B and B equals C, by syllogism, I can say, I can skip B and can we turn that off? We're going to have A equals C. So once again, if A equals B, we'll use this a lot, and B equals C, then A equals C. Substitution, if X plus A equals C, and A equals B, then X plus B equals C. Now, we're going to find out that these are two very closely linked things. Here is how I keep them kind of separated from each other. We only use substitution, really, if I'm substituting something within an equation. If you're replacing entire things, you're probably using the transitive property. And that might make more sense when we actually start using these. But that's the big thing. Most of the time, you can use substitution. The only time you can't use substitution, we'll get to that later, but most of the time you can use substitution in place of transitive as well. They're very closely linked, that's why we put a star by it. Algebraic properties, or properties of algebra. Do you see the one I have bolded? That's probably the only one you're going to use out of these. That's probably the only one you're going to use out of those. I feel like I'm missing one more that I didn't talk about. I'm missing an important one. And that's going to be the distributive property.
That's right. That's the one that's bolded. That's bull.
Oh, okay. I'm just ahead of myself. Oh, that's the one I bolded. Yeah, thank you. I meant to put it up there, and I put it down here with these. That's why I bolded it, because I bolded it to remind myself that I put it down there, and I still forgot I put it down there. Distributive property. We have to know the distributive property. Okay. Let us carry on and see what we're supposed to do with these. So when we're on things like this, when we have to state properties that we need to use, we can use these sheets to help guide us on what we're going to do, but we have to know how to read it. So what is the name of the property of equality that justifies that the first statement leads to the second statement? So your job is to look at the very first statement, which is 2x plus 9 equals 19, and then look at the second statement. Something happened between those two steps because the 9 is gone and the 19 is different. What happened between those two steps, Marco?
The 9 got subtracted.
They got subtracted. So all you have to go is, okay, they got subtracted. They got subtracted on both sides, right? So that means we're going to use the subtraction property of equality. So your job is just to realize what happened from step 1 to step 2. Is it subtraction, addition, multiplication? Did I already say division? Maybe I did. And then we add po onto it. If you don't have po on it, it's wrong. If you don't have po or a property of equality, then you are wrong. All right, what happens in B? How did I get from 1/4? Now be careful here because multiplication and division are two different things. Yeah.
You did. Oh wait. Well, I know which one it is.
Okay, pick one.
It's the division property of equality, right?
It's the division. So does that mean 7 got divided by a number?
Yeah. It got divided by. Or no, wait. It got multiplied.
It got multiplied by. Yeah, this fraction throws a wrench in our, because a lot of times we think it's division because there's this. We actually multiplied both sides by 4. So if you can't see that, I'm going to write it in. We multiplied both sides by 4. 4 times 7 is 28. So that's going to be the multiplication.
If it's a whole number, it's division property, right?
1 second. If it's a whole number, yeah, typically we're using.
Like 2/4, would that just be
It'd be multiplication 2 if it was 2 over 3. If you're multiplying. You have to be clear of what you're doing. If you're going to divide by a fraction, then it could be the division property. It's what you're using to get to the next step. Even if I would, I don't know. Let's just leave it as the multiplication property of equality. Don't overthink it. All right, so the next one, I went from 3 times quantity x plus 5 equals 9 to 3x plus 15 equals 9. How did I get there? I bolded it. Yes. Not the multiplication property. I did not multiply both sides by a number. Nick? It's the distributive property. That's the one I bolded for us because I distributed this 3 to this quantity. So it'd be the distributive property. Notice I don't have to put property of equality. There's only one distributive property. Okay, let's put this together into something that's more like we would have done in Algebra 1. We would have solved the equation. So I have 2 equations here. We need to solve them. Now, here is the hard part about this. What goes in these spots, so we're going to write something to the right of these, has to be how you got there. So, for instance, we go from 0.25x plus 2x plus 12 equals 39. And what we did is we put these 2 things together to there. So I need to put a reason on there. Now, this reason is not on your sheet. So you might want to pay attention to this. We're going to simplify this for you. We're going to simplify this by just putting this as simplify. When we just do a simple addition or collecting like terms, we're just going to put simplify. That is when we're just adding things together or subtracting things. We're just going to put simplify. I'll make things easier. Because sometimes we'll say collecting like terms. Sometimes we'll put it as distributive property. I'm going to make it easy for us, and we're just going to put simplify. All right, but here's the thing. We needed to put something up there. There has to be something next to each step. So all you have to say is basically, hey, Mr. Pabian, you gave this to me. That's how I know to start with this step. We're always going to start with something called given. You always start with a given. You have to have a starting point, and that's going to be our given. So given, and then we do something. So there's always going to be a given and something. Anytime you wrote something, it has to be how you got to that step. So now to get to this next step, it looked like I did something to the 12. What did I do to that? How did that 12 disappear? I subtracted it. Did I subtract it from one side? No, I subtracted it from both sides, so we use the subtraction property. Subtraction property of equality. Who can give me what the next thing I'd put down is? Raise your hand and tell me what's the next thing I'd write. I went from 2.25 and 27 to also having 225 to 2700. You might not have done that step on your own, but what did they do? How did I get from that step to the other step? Luke? They multiplied by 100. And we don't have to say what it multiplied by. All we have to put is multiplication property of equality. Because it's already been done, we just have to load. Oh, they multiplied. So they used the multiplication. I'm just going to change it to multpo, because that's what we're going to switch to. Multiplication property of equality. How'd they get from that step to x equals 12? Raise your hand. Yep.
Division.
Yep. Divpo, or division property of equality. All right, take a second and do the next one, knowing that your first step is given. So I'll actually give you your first one. It is given. As it usually is, we need to push through real quick. How did I get from step 1 to step 2? Just shout it out. I got the distributive property. I'll put dist prop for the sake of time. How did I get from step 2 to step 3? Shout it out. Adpo, our addition property of equality. Be careful that you didn't use subtraction, because I did add 8 on both sides. I added 8 to both sides to get to 72, so it should be adpo and not subtractpo. Last step, division po. I'll call it divpo. All right, the only next big step is can we do it by ourselves? So that means no? Okay. So first of all, you're going to be given something. So I'll give you something, so we'll write given. Your only job on the left-hand side is to pretend like you're in Algebra 1 and solve it. And I'll go step by step. So maybe the first thing I'm going to do is I'm going to subtract x from both sides. That's going to give me 2x equals 12. Now if I subtract it on both sides, that sure sounds like I use subtraction property of equality, right? So I'm going to put subtraction property of equality next to it. Subtraction property of equality. Can someone help me out? What would I do next to solve for x? Yeah, Mark. I would divide by 2, which means I'd be using that divpo, that division property of equality. So we divide both sides by dos, and we come up with x equals the old 6, and I'll just put division property of equality. Our next one's given. I would like you equals negative 4x. Oof, almost missed that. Minus 60 plus 54. That was our distributive property. Distributive prop. Now, our next thing is actually doing negative 60 plus 54, right? So our next step should look like this. 14 equals negative 4x. And we should have a negative 16. Any mistakes yet? Yeah, I would have 6 too. Make sure you are staying up to what I am doing. There's a lot of things to call this. My thing to you is just call it simplifying so you're not worried about stuff, but you can call it collecting like terms. You can call it just strictly adding, but do not put add-po because you aren't adding on both sides. That's why I'm like, if you're putting stuff together, just put simplify. I'm not doing things to both sides. I'm just going to simplify. Like I said, if you want to, you can put collect like terms. That is also a term that they use in algebra. If you're like, I know that one, use that one. I'm just trying to keep it simple, simplify. All right, then my next step, I'm going to add 6 to both sides. That will give me 20 equals a negative 4x. And if I added to both sides, we should know we're using add-po. Our addition property of equality. Now to get the 4 to the other side, I use division. I use division-po or div-po. So I divide both sides by negative 4, and I'll have negative 5 equals x. That is div-po. Now I did this in a particular way because that's not correct. We need to have x equals negative 5. And I heard it before. What lets me rewrite this as x equals negative? Because everything I do has to have a reason. Tito. The symmetric property. So I do need the symmetric property. So anytime I need to flip something, we're going to use the symmetric property. Symmetric property lets us flip stuff. All right. Do we know how to solve equations? I hope so. Our only job today is just putting those things on the next other side. Yes?
Why do you go from minus 5 equals x?
Well, yes, you do. Because we need it in a particular order. It's one extra step that's kind of dumb in proving stuff, but it has to be in the correct order to say it's proven. Because you're not going to say negative 5 equals x to someone, you're going to say x equals negative 5. So I'm just prepping you for harder proofs where you have to have it in that proper order. Okay, so we do it when it's simple, so when it gets harder, we just know to do it. Okay, we're going to go one step further. We're going to go one step further. And that is, we aren't just given a straight up equation, we have to come up with the equation. So that's what's happening here. We're given something up here. So it says angle AOM and angle MOC are supplementary. Now, here's something that we need to know when we get to proofs. Supplementary for me is a fancy word. A fancy word typically means I need to explain or define it. So when you see a fancy word, your next step is probably defining it, which means if you look at your sheets, these packets, if you turn the page over, you're going to see a whole list of definitions. Turn the sheet over and you're going to see a whole list of definitions. Is there something that says the definition of supplementary angles? What does it say?
Two angles in which the sum of the angles measures
Is 180. So it says if you have two angles that are supplementary, they equal 180. This is using the definition of supplementary angles. So if I needed to put a reason over here, I'd put definition of supplementary angles. And we're going to have to shorten it because I didn't give us a ton of room. Definition of supplementary angles. That's fine. Def of sub angles. That's the definition of supplementary angles. Let's try the same thing over here. Do we have any definitions for bisectors? Like bisecting an angle. Is there anything under definitions that say something about bisecting? A line that divides an angle into two congruent angles. I'm going to use the definition to say, okay, bisect means divide into two congruent angles. So I'm then going to say, okay, that means measure of angle RAB is going to be the same thing as BAN. As a reminder, your vertex has to be in the middle of when you name them. So we could have named this bar and nab, but the A has to be in the middle for both of them. So I use the definition of angle bisector. This is probably the biggest step we're learning today. If you see a fancy word, you usually have to define what it means. Because then it allows you to do your next step. So you gave me supplementary. I said, Mr. Pabian, that equals 180 by the definition. Now we can replace these angles with the information that's provided in those angles. So it says AOM is 2x plus 30. Replace. What does replacement sound like to you in math, Tito? Substitution. We are going to substitute part that AOM with 2x plus 30. So your next step is substitution. Let's see how that works over here. What can I substitute the measure of angle RAB with? I have RAB. I want to substitute it with more substantial stuff if I can. What can I replace RAB with? We can replace it with X. So instead of that, we'll put X. Someone else, what can I replace BAN with? Yeah. 2x minus 75. And once again, I use substitution. I just want to point out that proofs fall into like very small categories. These both are pretty much the same proof. They are define something and then substitute in the values that were given to you. And then we use algebra to solve those. So if I look at the left-hand side one, it says we have to go from 2x 30 plus x. Do you see how we added the two x's together? What did I say we can write that as? If I'm just adding 2x plus x equals 3x, what did I say we can call that? Simplify. I can call it simplify. I said another one too. Combine like terms. Either one of those work. I'm just going to put simplify. It just is easier for me.
Both be right.
Both would be correct. If you just put added 2x, that would work for me as well. All right, then we're going to subtract 30 on both sides. That's subtraction property of equality. And then finally, we'll have div po. I'm going to very quickly go through the other one because I want to go through homework with you real quick. Like I said, we have a shorter class. I'm going to go ahead and I'm going to subtract 2x from both sides. Now, the reason I'm going to subtract 2x from both sides is I get x on the right side. I don't have to use the symmetric property. So sometimes if I want to get away from using the symmetric property, I'll put the x on the correct side to begin with. That is a step to skip that one. So now I have negative x equals negative 75, and I just use the subtraction property of equality. And now I can divide both sides by a negative 1. It's okay to divide by a negative 1. Makes everything positive. We have x equals 75. And we used division property of equality. What was that?
Oh, never mind.
Okay. Sorry, I got to kind of push through. We only got like 4 minutes left. Be ready for a lot of properties that look like, or problems that look like this. Now, I'm talking about 3 new things. I'm talking about the reflexive, symmetric, and transitive properties here. So a lot of our stuff we're going to have is, I'm going to go from one step to the other, just like the algebraic ones, and you have to tell me, how did I do that? So if I look at the first one, I have O is congruent to W, W is congruent to L, so that means O is congruent to L. Do you see how we skip stuff? We use that law of syllogism to go from one to the other, connect it all the way through. That is going to be your transitive property. Whoa, that got away from me. Transitive property. Like I said, I pictured transitive. It's trains connected to each other, so they're all connected. I have O connected to W, W connected to L, so that means O is connected to L as well. What property lets me flip things? If it's not in the right order, what allows me? Symmetric allows me to flip it. And our final one is actually just the distributive property. I put this one in there twice because people forget about it all the time. They try to find some complex one. That's just the distributive property.